Hello, welcome to Science Chomp. Today we're going to be talking about free body diagrams. Now, what a free body diagram is a representation of the forces acting on an object. So let's have a look at some examples. Now, rule number one with free body diagrams is it doesn't matter what object it is represented by a dot in the middle, okay? Now, let's just say, for example, you have like a man standing on the ground. What you would have is the force due to gravity, and that would be going straight downwards like that. And you can label it Fg, that is the force due to gravity. Okay, F for force, G for gravity. You can also call it weight. Remember, it's a force is measured in newtons. And also, what you would have is a normal force, which should be exactly the same size, and you can call that Fn. That's F for force, N for normal. Now, the reason why it looks like this, if it was just like that, that would be unbalanced. And an unbalanced force basically suggests that it's going to be accelerating in this direction. And in this case, it's the downward direction. We know that isn't true because we are not being crushed into the ground, through the ground and into the center of the earth. And for that reason, there is another force going in the opposite direction. So this is what we would call a balanced free body diagram. And when something is balanced, it can only be doing two things. Number one, it could be stationary, which means it is not moving at all. So it's just staying where it is. And number two, it could be moving at constant speed. Constant speed. Okay, so one of the two things. When it's like this, where you've got just one arrow or an arrow and a smaller arrow, we'd call that unbalanced. And unbalanced free body diagrams lead to only one thing, that's acceleration. Okay, now be sure to watch the video on forces to see all of the different types of forces and see how they interact. There's one last thing I want to say. Sometimes you have, for example, a car. So you've got Fg, you've got the normal force, you have the applied force, so you could call that F applied, and you have two forces in the other direction. One of them's friction, and one of them could be air resistance. So when you're combining two forces in the same direction, you just add the arrows up like that. We don't want to see situations where you're doing things like that. This is incorrect. That's correct. That's Science Chomp for today. Thank you very much, and I'll see you next time.